Hey everyone, welcome to this 3D hex meshing tutorial. In this tutorial, we're actually going to be covering in detail all of the different features and functionality behind 3D hex meshing, and in particular using the solid mapping functionality. Now in this video, it's sort of broken up into two different parts. In the beginning, we do cover some of the basics and the terminology that will be used throughout the second portion of this video. I recommend kind of going through the first portion in order to understand what some of the basic rules are in 3D meshing, as well as some of the basic understandings of 3D elements, and then we go into the hands-on tutorial. So hope you guys find this video useful. If you do, I recommend you guys give a like and subscribe. Okay, so when we're talking about 3D meshing, we are talking about these 3D elements. So these are the four main types of elements that we're going to be working with, and these are really the only types of elements you'll see going around. So while we had the quad elements, which had 4 nodes on each point, right? So we had some quad 4 elements, which means they had 1 point on each one of the nodes, or 1 node on each one of the points. We also had triads, which had triad 3s, where they have 1 node on each point. And now we have hexa elements, which are these cube hexahedral elements. Then we have these penta elements, pyra, and tetra. So the difference between them is that a tria element is sort of a 3-dimensional triangular element where you have triads on each one of the faces. Hexa element is a cube element where you have quad elements all around the different faces. A pyramid is essentially a triangular top with a with a square bottom, and a penta has square sides and triangular faces. So the big difference between the two, or the main things about them, is that hexa elements and tet elements are essentially the same thing as the tria, and we treat them the same way as the trias and the quad elements, right? So just like before, preferably we want to have hex elements, but trias are way easier to mesh something, and I will show you guys how it plays out. Now, pyra elements and penta elements are more transition elements, where if you start with a hex mesh and you're moving on to like a triangular mesh, then these elements are generated between the two to make that transition between the hex and the triad. So that's what those two elements are there for. Now, the way that we're going to be doing, and here's some basic terminology that we're going to be using. We have to divide the geometry. That's really the most intricate part of 3D mapping. When we're talking about these faces, we're going to see a geometry, we're going to split the geometry, but the main terms that we're going to have are these partition faces. So the partition faces are a face where the geometry is split, but the software knows that they're connected. So when you generate a mesh for one, it'll make sure that the mesh for the other matches that geometry. So these partition faces are going to be colored in yellow, and we've got to make sure that those are all together. Whenever you have a certain geometry that you want to make sure that it matches another geometry, you always want to make sure you have these partition faces between the two. Then sometimes when you make a very thin cut that doesn't go all the way through, you'll have these fin faces that will happen, and this is more of an error, so these are the ones you want to watch out for. So these fin faces are the ones that you want to kind of like avoid when you're doing work. So then when we're talking about mapping, we're going to grab a geometry, and we're going to have what we call a source face and a destination face, because ideally what we're going to be doing is, well, technically the software is going to do most of the work, but you're essentially going to be generating a 2D mesh on the face of this, and then you're going to be extruding that, or kind of dragging that mesh through the geometry to the destination face, and that'll generate 3D elements through the actual geometry that you're working with. Now, the thing about this is that when you're working with source faces and destination faces, you can have multiple source faces. So this could be divided into multiple faces, but you can only have one destination face. And this is a very important rule to understand when we start doing this. But ideally, that's the process. We're going to be grabbing this surface, the source face. It's going to mesh, auto mesh on its own. It's going to mesh this face. And then it's going to grab that mesh and just kind of drag it in this dragging direction along the geometry here. Now, when you're looking at something like this, it makes a lot of sense, right? You can grab this source face, you can drag that mesh through here, and it'll reach that destination face. But once you work on a complicated part like this one, where you have all these different things going on,
then it becomes a challenge because you don't know where the source face is, you don't know where the destination face is, and you kind of have to divide it into pieces where you can have a source face and a destination face. So in this case, they grab this geometry, and as you can see by this third one here, you partition it, you divide it into these, and hopefully you guys can see my mouse, right? I don't know if you guys can see my mouse. So here you have these, for example, these partition faces, and you can use, you're pretty much dividing the geometry into these meshable parts, these meshable components. So then what you end up doing is they split this geometry by this top part, this bottom part, and then they separate this triangular part. So then they use this method of selecting the source face and destination face and dragging the mesh through it for each one of these little components here. So then, as you can see here, the first one they mesh is this one. So they use this as the source face and that one as the destination face. And they drag that through the thickness. Then they grab this one and they do the similar thing where they mesh this front face, and the back face would be the destination face, and they just drag it through the thickness in that direction. And then this bottom one, they do a similar thing where they mesh this front face, this top face, and they choose the bottom one as the destination face, and it'll just mesh it through the bottom there. Now, when it comes to these mapping directions, you don't have to have a perfect, you don't have to have like a square front and a square back. You can start with a circle round front and map towards a square back if you needed to. So you can mesh some fairly complicated things, but you just got to follow these rules of making sure that you have one source face, right? So you can only have one source face, or you can have multiple source faces, but you can have only one destination face. And being able to have a drag direction, where the drag direction, you have to watch out and make sure you don't have any edges that are perpendicular to the drag direction. Okay, if you ever have an edge that's perpendicular, then you can't use that drag direction. You have to suppress those lines like they do here to be able to have a map direction in this direction. So then here, for example, they mesh this face, and then they drag the elements through that. Now that'll give you some really nice quad elements that will be very useful and very clean, and you'll get very good quality results, and that's why everyone in aerospace uses them. But the thing is, to do all of this work takes some time, right? So this will take some decent amount of time to divide the solid, making sure the solid is divided properly, and then sometimes you'll divide a solid in a certain way and it might not work and you have to do it again. So 3D mapping can be time consuming, but it'll give you the best quality mesh. Now, what I want to show you guys here is that there's more than one way to do things, and this will come with experience as well. So when you're doing a 3D map, there's multiple ways of doing it. So for example, here they separate this by each one of these faces. So they cut this solid along this face here, along this face in the front, this face in the back, and you get all of these different partitions going through it. So then this is what your mesh would look like. But on the contrary, if you partition it at an angle, then you'd only have 4 partitions as opposed to, what is this, 6? So then you'd have your elements skewed off a little bit, but then you have less elements to worry about, right? Because this would have smaller elements going through it. So all of these things take time to learn and experience, right? Now, with that, I want to kind of just show you guys what 3D meshing is all about. What I'm going to do is I'm going to start a new session. So I have a clean session here, and I'm going to import a model. So I'm going to do this optional part here. And again, I'll shade the geometry. Now, this is going to be probably one of the most complicated things that you'll be doing when it comes to hypermesh, or really FEA in general, any software you're working with. Making sure that you have a good mesh is usually the most time-consuming part. Luckily, hypermesh has a lot of tools that make it easier and helps you check and make sure that everything is done correctly. Now, in this part here, I'm going to try to do it a little bit quickly here, so you don't have to follow along. You can just kind of like watch and see what I'm doing. And when you do the exercise, you'll be able to actually practice it yourself. But this is a fairly intricate part here, right? This is a small little component, but it can get fairly intricate. So what we can do is you first kind of have to kind of plan it out and think, okay, how am I going to split this? Where am I going to start meshing it from? And how am I going to do this whole thing? So you can start kind of looking at it and planning where you want to cut it from, right? Now in this case, I could probably separate this front part here, this hook part, and just mesh that on its own, right? I can then divide this probably from this face and just have this solid part here. Then I can separate this cube part here and mesh that on its own. And then I can separate this bottom part here and mesh that on its own, right? So that's you. So you kind of have to come up with a bit of a game plan. And these game plans, you know, sometimes they work. Sometimes you might have started at the wrong place. You'll find, oh, maybe I should have started here instead of here. But again, that's all with experience. So enough talking. I'll start kind of showing you guys what this is about. So here we have this section here that we could probably divide. So if we want to edit and kind of split this geometry, what we need to do is we go to geometry and we go to solid edit. Now in solid edit, then we can go ahead and generate this or split the solid. Now here we can see that it's all in gray, which means that this is a surface. It's not necessarily a solid. So we need to create a solid to make sure that we can edit the solid, right? So first we need to generate a solid from this. So if I click return and I go to solids, then I'll go ahead and just generate a solid using bounding surfaces. So here I have this option that says bounding surfaces, and I can just select all of the surfaces and just create a solid out of all of the surfaces. Now you have to make sure that your surfaces don't have any free edges. If you have any red edges, anything that's not connected, it's not going to be able to generate the solid for you. So what we have to do here is we can start changing the solid here. Now notice the color difference. If it's green, this transparent green, then you know it's a solid. If it's gray, you know it's a surface. So now I can go to the solid edit panel here, and I can go ahead and just change this and split this geometry, right? So if I go to the different options that I have here, you can see that I'm able to do all sorts of different edits, and there's no one correct way of doing it. You just kind of have to try and figure it out and work on your, like, you kind of have to, you learn how to use a lot of these things here. So then what I'm going to go ahead and do is I'm going to separate this horseshoe shaped part, and I would probably split it from here as well, right? Just to make it a little bit simpler. So then what I'm going to go ahead and do is I'm going to select trim with lines, and I'm going to select the solid that I want to trim. Now remember, keep in mind, these are all 3 different individual tools. The one I'm going to try and use is this sweep lines, which means that I can grab this geometry and I can just sweep it along in a certain direction. I can select a line and just sweep it in a certain direction and make a cut in that direction. So what I'm going to go ahead and do is I'm going to select the solid using this tool because I need to stick with all of the ones in this section here. I'm going to go ahead and grab this geometry or this line here, right? So I want to use that line to cut through the thickness of this, right? So then I need to specify a direction. Which way do I want to cut this, right? So this is going back to what I showed you guys at the beginning, and this is why I put so much emphasis on it, because you use this a lot. So if you want to cut through this thickness, then you can go ahead and select either N1 and N2, right? So we can just click here, and that'll specify a vector in that direction. So I can go ahead and click trim, and you'll see that it used that line to just kind of infinitely cut through this geometry. If I made a cut that I didn't want to do, like for example down here, I can use this merge option and just select the solids that I want to merge, and I can just simply put them together. Okay, so that should be good there. Now the next section that I want to cut, right? So here I can go ahead and map this, no problem. So let's go ahead and do that. So in order to do a solid map with solid elements, we need to go to 3D now. So we're going to go in 3D, and on the far left option here, we can go ahead and select the one volume, right? So we have this option for one volume. And now that I have the volume that I want to mesh, I just go ahead and click that part there. I select an element size. Let's do, I guess let's do a size of 1. Hopefully that's not too small. And then I go ahead and click mesh. Now here you can't see the mesh because, as you can see by my components, the mesh is hidden. So now you can see the mesh that it generated. So what it ended up doing here is it ended up grabbing this solid. It selected one of these faces. It's kind of hard to tell which one, but it selected this front face here, and it just mapped through the thickness of that part, right? So that's what it ended up doing here. So now we can go ahead and try and do the same thing for this one here. So for this, I would need to split off and separate this half of that horseshoe and separate it from this surface here. So what I'm going to go ahead and do is I'm going to use the trim with lines. So I need to go back to my geometry edit. So I click return, geometry, solid edit, and I'm going to use lines again. Now this case though, I think I can just select all of the lines around here. So I can use this bounding lines option. So I can click here, click lines, and I can select all of the lines that are around the geometry, right? So it'll know to split it off from those lines. So if I go ahead and click trim, you'll see that I have a partition there. And remember, these partitions, what they tell you is whatever mesh I have here, it has to match whatever mesh I have over here. Now, if I wanted to go ahead and map this, I would have to first try to select a surface face, right? Now, if you look at it closely though, there is a bit of an issue with this part here. Yeah, I could do the similar thing like this, right? I could select this front face and map it through the bottom, but you got to keep in mind the rules that I was mentioning. You can't have any perpendicular lines, like I was showing you here, right? You can't have any perpendicular lines from your drag direction. So if you look at this part here, this line, if we select this as our source face and the bottom as the destination face, then the mapping direction is along this line. So that line is parallel, so that's fine. That line is parallel, that one's fine, that one's fine. So everything seems fine, but over here, we have this line that's perpendicular, right? It's against the map direction. So we cannot map in that direction. And since this is attached through there, you can't really get rid of this part, right? You can't suppress these edges, for example. You can't suppress them because they're attached to this component. So we have to kind of think of it a little bit different now. We have to change our direction. So instead of mapping from top to bottom here, we can try to map it from right to left, right? So we can go from this face to this face. Now keep in mind what I mentioned as well, where I said you can have multiple faces on the source face, but only one at the destination face. So in this case, if I look at how many faces I have, and I'll do that by, I'll just to show you guys, I'll select the masking tool and I'll change this to surfaces just to highlight which surfaces I have. I have 1, 2, and then I have this other one here, right? So I have this middle one there. So I have 3 surfaces on my source face, and my destination has 1, 2. So there's an issue here. We can't have more than one on our destination. We can have as many as we want on the source, but we can't have multiple on the destination. So what I need to do is I need to suppress this line to make this one surface. So if I go to, again, quick edit, and I use toggle, and I select that line, that'll suppress that line, which means it's ignoring that line, which means that now this is one surface. So if I show you guys again with that, if I click on it once, you can see that it detects it as one surface instead of 2. So now I only have 1 on my destination and I have multiple on my source. So then what I can do is I can go to 3D, solid map, and I can select one volume and select this and mesh it. Now, I'll go ahead and leave that as it is now. Well, actually, let me just go ahead and mesh it to show you guys. Well, actually, no. Let's move on to the next part. I want to show you guys something else here so that you can see how you can mesh multiple solids at a time. So I'm going to assume that this is okay now. So I'm going to move on to this next section here. And you kind of work your way along the part here. So now I'm looking at this section here, right? I'm just going to cut it from this face here. So I go back to my geometry. I do solid edit, and I select this part here. So now I need to cut this from that face. So I can use trim with planes and surfaces. So I can select this here, and I can select this surface here, right? And just trim it along that surface. Now I made the mistake that I was telling you guys to watch out for. Keep in mind this is one tool, this is a separate tool. So if you select the solid here, it's not going to work. You have to select it over here. So now I selected my solid, I selected my surface, and I go ahead and trim it. So now I have one solid in the middle here, right? So that's one solid. So now I can have this as my source face and this as my destination face, right? But the issue is that I have these perpendicular lines here. So I can do a couple of things. I can maybe cut this here. I can just cut that solid from that line. So for example, I can do this here. Now, there is one way to be able to tell if a solid is mappable or not, if you have something that is not mappable. So what I want to go ahead and show you guys here is I can change my view from auto to this one here called mappable. Now, you can see how it changed here, the colors of everything, right? Which means that components that are clear like this are mappable. So I can generate a solid, no problem, or I can generate a mesh for that, no problem. But this solid here is not mappable as well as all of these other ones. So you can kind of be checking how mappable your part is and where you might have a problem, right? So in this case, what I'm going to go ahead and do is I'm going to go ahead and separate this from this perpendicular line, right? So that it doesn't have a perpendicular line for the mapping direction. So then what I'm going to do is I'm going to select lines, and we can select with N1 and 2 the direction, or we can use the global axis. And in this case, I can see that the Y direction is pointing in the direction I want. So I can just choose my direction as Y. Select my solid, my line, everything's set. So I click trim. You can see that it goes ahead and trims this surface, right? And now that it's clear, it's mappable, which means that you can select this as your source, this as your destination, and there's no perpendicular lines, right? So everything is fine. Although over here, we have some issues because we have these perpendicular lines. So this is not mappable. So we can probably, like this, even though it's curved, it's moving along in the direction of the map. But these are not, so we can just suppress these two here. So what I'll go ahead and do now is I'll click return. I'll select, let's see, select quick edit, and then we use toggle again. We select those two lines and we toggle that. So now the next section is over here. I'm going to try to separate this from the bottom here. And now I'm going to move a little bit faster just to kind of move along since you guys get an idea of how you need to separate this. So now if I start separating this, I'm going to select this here. I'm going to trim it with this surface here. That's going to split it off like that. So now I have this as my source face and this as my destination face. So these two lines up top are causing problems. So I need to suppress those two. And I'm going to move very quickly now. So I'm going to start doing this. I suppress those two lines. Those are perpendicular. So now I have a mappable solid there. So now over here, I need to separate that spherical part from that solid part there. So just go ahead and use solid edit again. Select the solid. Actually, we're going to do lines. So select with lines. Actually, we'll select this line on top. And I will select direction using this, N1 and N2. And that trims it. And now you can see that we have most of it mappable now. So now that you've separated most of the solid, I mean, I can go as far as separating this as well. This takes a little more time, but that gives you a fairly good idea. So now that I know that my solid is mappable, I can go to 3D, solid map, and I can do multi-solid now. So with multi-solid, I can go ahead and select all of these solids and mesh all of them. So I can select all unmeshed solids, except for that one. That one's not going to work. And I can go ahead and click mesh. Now when I click mesh, you can see that it gives me a preview of the different meshes that it's going to be generating. So here it tells me this is the source face, this is the mesh it's going to generate. And then you can see that it produces a line that tells you which direction it's going to be mapping it to. And then on top of that, it tells you the order that it's going to be mapping it in. So it's going to map this one first, then this one, then this one, then this one, then that one, using these meshes. You can make adjustments to these meshes if you want. Like let's say if you needed to make a change to this, I can change the edge here from not 1. Let me reject that. Probably like, let's see, you can change it to different value, like you can do like 10, for example. You can select that edge, generate 10 elements. In this case, I'm just going to go ahead and leave it, but you can make adjustments to the mesh. And then once you click mesh on the right here, it'll go ahead and mesh all of the parts for you. And it'll do it in the order that it was mentioning. And that goes ahead and generates a nice hex mesh for you. So now you can see that I have very nice clean elements running through my geometry, and it's mostly hex meshed in this case. So this is the basic process of doing a hex mesh.
Well, everyone, thank you so much for watching. I hope you guys found this video useful. In the next segment, I will be covering tetrahedral meshing, which is similar to this. So please stay tuned and be sure to like and subscribe for more content like this.